So, hello friends. So, as you know, in the previous lecture we studied about it was the last lecture of monopoly, and we studied about the regulation of natural monopoly and effect of lump sum taxes and unit taxes on the monopolist, right? And we saw that from the consumer and government point of view, the lump sum taxes are better. Okay, so now in this chapter we will discuss about oligopoly. Now we have started oligopoly, and our monopoly was finished in the previous lecture only. Okay, so what is oligopoly? So the main feature of oligopoly is that there are few sellers. So by few it means that it should be greater than 2, and the maximum quantity is not specified anywhere. If you know, and if you have read somewhere, then you should mention in the comment box with the source, so that I will also edit my video and tell to it. But till now there is no specified number, and it's different from different authors, so we cannot just give some one number. But we know that it should be greater than 2, because if it is equal to 2, then it will be known as duopoly. Like for example, Coca-Cola and Pepsi, there are a duopoly firm. Like duopoly means duo, two firm operating in the market, right? So if I want to give you the example of oligopoly, I can write here few sellers. So if I want to give the example of oligopoly, I can take out the airline industry. You can see in the airline industry, there are not many sellers, there are few sellers. Like if I take the example Vistara Airlines, SpiceJet, and British Airways and Etihad, they are big firm, and few sellers, right? Okay, so now we will come on to the types. So there are two types basically which we will be discussing, mainly two types. So one is collusive and other one is non-collusive. So what is collusive? So collusive is the one, like if the firm cooperate with each other in determining price or output or both. Like they are determining the price with combinedly. Like they are not going behind each other's back and charging different prices. They set up their meeting, they fix that we both will sell at this price, and they follow regularly. They follow that price only. They don't deviate from such price. Okay, though they can compete through another cost, which is like advertisement cost. They can compete through advertisement cost, but they won't chase their price or output whatever they have discussed in their meetings. Okay, and similarly the non-collusive is the vice versa of the collusive one. Okay, so if firm in a non-oligopoly market compete with each other, now they are not determining prices or output combinedly. They are competing with each other, and they are charging their different prices and playing their different prices and output strategies, whatever they might be playing. So they are not so they are operating the business independently, right? They are not combinedly setting the price or output. It's independent. He is following his strategy and he is following his strategy. So there is no relation between two. Okay, so this is non-collusive. So we mainly deal with collusive in our syllabus. Okay, so if I want to tell you the definition of oligopoly, so it refers to the market situation in which there are few firms selling homogeneous or differentiated products. I've already told you this. Okay, so now we will come on to our first model. There are total three models in oligopoly which we will be discussing. First one is Cournot's model. We will be discussing this now, and if I tell you what is the second one is Checkelberg, and the third one is Bertrand's. Okay, so these are the three models which we are going to study now, and we will start with Cournot's model round. So for each models there are some assumptions. They carry some assumption that under this assumption we can apply this model. Okay, So what are the assumption of this Cournot model? So there are four assumptions of this model. So what are these assumptions? So first of all, the first assumption is that there are two firms selling homogeneous good under constant cost of production. That is, MC is constant and they both are selling homogeneous goods. Okay, that means the buyer cannot differentiate between the products of both the sellers, like they are homogeneous. He cannot differentiate between the two. Okay, so he won't be paying extra prices to any one of them. Okay, and the second assumption is that they sell their output in a market with linear demand curve. So that means that the relationship between the price and the quantity demanded is 1 to 1. Okay, that is, consumers are willing to pay a certain price at a certain point of time, right? So the third one is that each firm, in order to maximize its profit, assume that the other firm holds its output as constant. Like if I am the first firm, and so what if I have to maximize my profit, I will make the I will hold the output of the other firm constant, and then make my expectation or do the derivatives and all after making the output constant. Like I will assume he is going to produce 50 units this year. Accordingly, I will set my output or price in the Cournot model. I will set my output, because in Bertrand's we set price, and in Cournot's we set our output, keeping the other firm output as a constant, right? And the fourth and the main assumption is that both are equal rivals. So what does it mean by equal rivals? So if I give you the example, like first we take the example of Apple, and then one company is Apple and another is Vivo. So if you see, Apple is here and Vivo there is this one. Vivo is this pen and Apple is much higher than that. So they are not equal. They won't be considered as equal. Now if I take the example of Oppo and Vivo. So Oppo and Vivo are equal company. Got it? They are equal company. They are called as equal rival, like Oppo and Vivo. Got it, guys? Whose core structure is basically similar. Okay, so guys, we will start with some rough work. Okay, for just clarity only, I'll take the demand curve. Let the DD curve be P is equal to 250 minus Q. And what is Q? Q is equal to QA. We are taking only two firm here in the example. Okay, and MC is constant. MCI is equal to 50 and I is equal to A or B, or you can write I is equal to AB, or you could write 1 or 2. Okay. So what does here P shows? Here P shows that the goods of company A and D are homogeneous. That this demand function shows that the goods are homogeneous, and so that the consumer, it means that the consumer cannot differentiate between A and B's good. So he is willing to pay same price for both the good. This is main thing you should know. This is of quantity of firm A and this is quantity produced by firm B. And MC, if you write it here A, then also it will be same for both. And it was our assumption also that MC is constant for both of the firm. Okay, guys. So now what we will do now, that we will see from A's point of view. So what do? We will keep the output of P constant, and we will make it constant by assumption. We will assume that make expectations that he will going to make this much output, so I will maximize my profit accordingly. So we will draw some table and we will take different output and we will see what will be the output A will be producing. Okay. From A's point of view. Okay, so output of B, I'll write it here, and here I will write profit max. Profit maximize OT of A, right? So now this is assumed by A, this output of B. It is assumed by A on his expectation. He is expecting. So first let's see, the A is expecting that B will produce only 0 output this year. B will produce 0 output this year. So what would be the output of A? Okay. So what will be the profit maximization output of A when he assumed that output of B will be 0 this year? So you know that the demand function was given as this. So we have to calculate first TR will be P into Q, and if you calculate this will be 250Q minus Q square, and then MR will be 250 minus 2Q. So since you were given that Q is equal to QA plus QB, so now A has assumed that B will be 0, so this will be 0. So now Q is equal to QA, so you can directly write it will be equal to QA. So you can equate directly 250 minus 2Q is equal to your MC. MC was given as 50 if you remember in the previous example. So you will get QA is equal to 100. Okay, so you can write here 100. So okay, so now next year come, and next year I'm not talking about actual what he has produced. I'm talking about expectation. Always remember that. So next year I thought that he will produce now 50 units. So I will see accordingly now what should I produce now. So now again I will do the same thing. We have MR, we have Q is equal to this. So now if you see that QB is equal to 50. So what will be QA? QA will be total Q minus 50. So now what you will do? Now you will write here, from in place of QB you will write 50. So what will be your demand function now? Demand function will be equal to minus QA plus 50. You will directly write that Q is equal to QA and 50 we have assumed. So we have write this. So what will be your demand function will be 200 minus QA. Similarly, if you calculate MR from this directly, I am writing it will come as 200 minus 2QA. If you equate it with MC, I am directly doing it. What you will get? You will get QA is equal to 75, that is 150 by 2. So you can write 75. Okay, so similarly if I assume that output of B, what can be the maximum output that B can produce? So it will be 200. So he is assuming now that he will produce 200 units now. Okay, so what will happen now if we produce 200 units? So we will again do the same thing. We will write here in place of QB, we will write what we will write? We will write that it will be QA plus 200. Okay, so you can write P is equal to 250 minus QA plus 200. So what will it come? It will come as 50 minus QA. Similarly, if you calculate the MR here, you will get 50 minus 2QA. I am equating directly is equal to 50. So you will get QA is equal to 0. So he will produce 0 unit. If he assumes that he is going to produce 200 unit this year, he will produce this unit. So you can easily draw one graph on the basis of this information you have given. So I will make the graph. We will make the graph now. So we will make one graph now. Okay, so this is your output and this is your C and R, cost and revenue. Okay, so if you see what was your first demand function, what was your first demand function was when output of B was 0, output of B was 0, then at that time your demand function was this QA, it will be here QA. So you can write down, you can make your demand function, we call it as DA. When the output of B we assumed at 0, so it will be 250 comma 250, right? And similarly if you draw MR correspondingly, MR, and you will draw MC also, and it will be of MC of A because we are drawing in respect of A. So at the first case when we equated the MR, when we assume that output of B will be 0, we got the profit maximization output to be 100. So we can directly write it here, 100 units, right? Now we will come on to the second point. When we assume that the output of B will be 50, we had our demand curve this. We had our demand curve this. So if you calculate this, this will come as 2200 minus QA. So if you plot this in the graph, you will get something like this. I'll start from here. This is your 200 intercept, and similarly we will draw one MC, sorry, MR corresponding to this. So this is 100 not 1000. So you know which point it will pass through. It will pass through its half of its slope. So it will pass through 100 because this is 200, so and this is 100. So this MR2, and we call it DA1, DA2, this will pass through this point. Okay, and what will be the quantity? We have already calculated it. The quantity was 75. So okay, so now we come on to our last diagram, our last point, when we assume that the output of B will be 200. So when the output of B was 200, we have seen that our demand function has came to be 50 minus QA, right? And your MC is also 50. So if you make the demand function here, what will be your demand function? Here there is some point 50, let's say. So your demand function will be like this, and this will be your MR3, and this is your DA3, right? See, this is your MR3 and there is some point, I'll drop this 75, and there is some point 50 here. So this will be your 50-50 intercept here. So I joined this. So you will get your third demand curve when the output of B is 200. So similarly, the profit maximization of output of A will be 0. So where will be the equilibrium come? Equilibrium come at this level. Okay, so he will produce 0 unit at this point when A, then before the equilibrium of 2 was this and equilibrium of 1 was 3, E1, E2 and E3. So now if we have to plot this now in single graph, so what we can draw is like, if you want to bring out the relationship between quantity of A and quantity of B, so we can easily draw out relationship with this also. You can plot this point into one diagram. Here we write QB, here we write quantity by A. You can say the maximum quantity of A is 100, so we can mark here 100, and maximum quantity of B is 200, so we can mark here 200, and if we join them we get one linear straight line, right? And what is this? What is this linear straight line? This we call as reaction curve of A. This is called as reaction curve of A. So I made reaction curve of A by keeping the output of B constant through my expectation. I expected these output and similarly calculated my profit maximization output at these level, these which I have shown. So I have calculated reaction curve of A according to this. So this is very much complicated. It won't be, don't have to do in the diagram all this. You have to start directly from this point. You have to directly calculate reaction curve of A, and which is very simple. This was just for the conceptual clarity for you guys. Okay. So now I will teach you that how do we calculate the reaction curve. So first of all, what do we do that if we want to calculate the reaction curve for A? What do we do that we will do its profit maximization by keeping the quantity of B as a constant, right? So what will be the profit function of A? We all know that TRA minus TCA, right? So this can be written as TRA minus, what is TC? We have given MC. We will integrate with respect to Q. Also, if there is some TFC, we will add this also. But in this question, we have not given the TFC, so we will assume it to be 0, right? So this can be written as T into QA minus MC. We have given 50, so 50 QA, it will be 50 QA, and TFC is 0, so we will take it as 0 only. So now we will keep the value of A from the given above your demand function. This was your demand function, P is equal to this plus this, and in the place of Q we will write QA plus QB, which is given. So we will just substitute this value in the equation. So it will be 250 minus QA minus QB into QA minus 50 QA. So if you solve this equation, you will get 250 QA minus QA square minus QB QA minus 50 QA, right? So what do you do to maximize the profit? We do the same thing that we first derivative and put it equal to 0. So del pi A upon del QA is equal to, which will be equal to 250 minus, it's simple, 2QA QB minus 50. Now what do we do that? We put this equal to 0. I am putting it here only. I am just saving some steps. So this will come as 200 minus QB upon 2, which is equal to QA. And what is this? What is this equation? This equation is nothing but reaction curve of it. Wasn't it easy? It's damn easy, dude. It's damn easy. So this was the reaction curve of A, which we already drawn here. So we calculate the equation of this curve like this. We don't have to go through all this and do this much. We have to directly calculate from the profit function and maximize it by derivating it for the first time and then putting it equal to 0, and the relation you get between the QA and QB will be your reaction curve of A if it's pi A, and similarly you do with pi B for the B, and you will get QB in terms of A, and this will be reaction curve of B. And for the answer, the equilibrium point, what you have to do, that you will see where both the reaction curve intersect, reaction curve of A and reaction curve of B. At that point is the equilibrium level, and that level the profit of both the firms is maximized. Okay, so now similarly I am writing similarly do for B, firm B. So you will get pi B is equal to same procedure, TRB is equal to TCB. As you can see, the value are not that much different, so it will be just interchanged only. So I can directly write 250 minus QA minus QB into QB minus 50 QB, and this is equal, if I derive it directly here from here only, QB, you will get 250 minus QA minus 2 QB minus 50 is equal to 0, and this implies that QB is equal to 200 minus 200 minus QA upon 2. So this is the reaction curve of P. So you got two equations right now. You got the first equation is this, RC of A, and second equation is this, RCB. So if you solve these two equations, you will get your final answer. And this is all what we have to do in Cournot's model. Your question will come, you have to first find the reaction curve of A. If there are more than two firms, that you have to find the reaction curve of all the firm, and then similarly, as you find the solution for the given equation, you have to just solve two equation or n number of equation, whatever the number of equation will be, and you will solve the equation and find out what will be the intersection point and what is the common point which they are getting. Okay, there is solution. So if we draw reaction curve of A, we have already drawn that it had 200, 100 intercept, and if we draw the reaction curve of B, 200. So now if you solve these two equations also, you will get your answer as, you will get your answer here 66.66. So if both the firm produce this much quantity, their profit will be maximized. Okay. So now if I come to theory, that so I can say that Cournot's model is an example of oligopoly industry in which firms are assumed to determine their output such that output produced by the other firms remain constant, like we did here, that we for the first time we make the output of V constant, and for calculating the reaction curve of V, we kept the output of A constant. We did the here also. So what we do to calculate this, we will use the concept of reaction curve, and reaction curve is also known as best response curve. Question it can also come that you can calculate through best reaction curve, so don't get confused, it's one and the same thing. So what is reaction curve? If I come in theory, so reaction curve is nothing but they represent the profit maximizing output produced by one firm for a given level of output produced by the other firm. What reaction curve tells? It only tells the different combination when the output of one firm is kept constant. So how much output can what is the profit maximization output of the other firm? It only tells its combination, the different points of such thing. Okay, okay guys. So under Cournot's equation, firm determine their output simultaneously by intersection of their best response curve. So the word simultaneously is important here, that they are determining their output simultaneously, right? They are not, it's not like that I am determining my output first and after that you are determining, and I have knowledge of what are you going to produce, then I will profit maximize my output according to that. So it's occurs simultaneously because both are equal rival firms. Okay. So guys, concept and numerical I have both combined, and I have tell you the theory also. So our Cournot model is finished, but we will do one more question, and I will give one question for your homework. Okay. So the question is, let market demand function be market DD P is equal to A minus Q, where similarly Q is equal to Q1 plus Q2. So what you have to show is that under Cournot each firm produces one third of competitive market output. You got the question right? And assume that the cost of production is zero. Cost of production is zero. That is MC is zero, so TC is also zero. Okay, that the question is saying that demand curve is given as P is equal to A minus Q and Q is equal to Q1 plus Q2. So under the Cournot's assumption, each firm produces one third of the competitive firm. What is competitive firm? Where the condition is price is equal to MC. That if the competition firm, this is the competition firm, that the output was the competitive firm was producing. So the output is one third of the output produced under the assumption of Cournot model, which we just studied. Okay, guys. So what we will do? We will do the same thing. We have to first calculate the reaction curve of A, then reaction curve of B, then we will finally calculate the quantity of 1 and quantity of 2, which will be going to come equal. As we see in the previous example, that quantity of A and B will be both this 66.6, 66.6. So they will come equal. So if I calculate for, let's say, firm 1, okay, so what will be profit function of 1? It will be TR1 minus TC1, right? So TR1 will be P into Q1 minus, you have already given that cost of production is 0, so TC1 will be 0. So what you get now? This is A minus, in place of Q you will write this, minus Q1 minus Q2 into Q1, 0. Again we will differentiate Q1 with respect to pi 1 with respect to Q1. So what you will get? You will get del pi 1 upon del Q1. I've used del because there is more than one variable. Okay, so and I have assumed the other variable constant. So that's why we have used a partial derivative, not direct one. So we will get, if you want to write in respect to Q1, this will be equal to A minus Q2 upon 2. This is your RC1, reaction curve of form 1. So similarly, if you calculate of 2, they both will just interchange. So I am writing in short only. You have to show in exam. You cannot write it shortly in exam. I'm just writing here shortly. So it will be Q2 minus A minus Q1. We have just interchanged Q2 and Q1 upon 2. So this is RC of 2. Right, now what you have to do? You have to solve RC1, solving RC1 and RC2 we get. I'm keeping space here for perfect competition. So if you solve this, you will get Q1 is equal to A minus, I write the value of Q2 here, A minus Q1 upon 2. So you get here, if you solve this, you get 4Q1 is equal to 2A minus A plus Q1. This implies you get Q1 is equal to A by 3, which will be equal to Q2 also. I've already showed you that it will come equal since the demand curve is linear, and already we have done one example where they have come equal. So it will, and if you also solve also, don't go by this that this will always come like this. You only solve it full, then only you can see. or because this is just the interchange of both, that's why their answer is coming same. But I would suggest you to solve the full question, and also you have to solve the full question in the exam, so better practice to solve full in your practice session only also. So we got this quantity under Cournot. So what now you will see in perfect competition, what happens is perfect competition, you know that the equilibrium condition is P is equal to MC. That means A minus Q is equal to 0. This implies Q is equal to A. So what does it tell you now? So now you can easily see that the quantity which is produced by when there is perfect competition is one third. The quantity produced under Cournot's assumption is one third of the quantity produced by the perfect competition, right? Since you can clearly see the quantity produced in perfect competition is A, and under Cournot's assumption is A by 3. So we have proved what was asked in the question. So your question is solved now. Okay, so you can write hence proved. So now I am giving you one question for the homework. Okay, so homework. So the question is, let the demand function be, let the market demand function be P is equal to 100 minus 0.5 x. X is the quantity of market. X is equal to XA plus XP, right? And the total cost function is given. Function is, it is now different for both. For A it's 5 of XA, and for B is equal to 5 of XP. So I was saying that the quantity will not always come equal of both, so it will happen when the cost function of both the firms are different. In this question, if you solve this question, you won't get XA is equal to something is equal to XP. No, you won't get this. You will get both the different values of XA and XP because the cost function are different. So you have to just calculate the quantity which will be produced under Cournot assumption, and I'm just giving you the final answer so that you verify with your answer. XB will come as 30 and XA will come as 80, and profit of A will be 3200 and profit of B will be 900. So with this, our Cournot's model is finished, and in the next class we will discuss about Stackelberg model. So guys, if you have any doubt and or any query, you let me know and mention me in the comment section. I can make live videos also for your queries, and but just you let me know what is your demand and I will try to fulfill all your demand. Thank you guys, thank you for watching.